friends, and welcome back. Miss Bertuman here. Today we're going to be using the area model to solve division problems without remainders. Let's begin. You'll see on my paper I've drawn a rectangle with an area of 48 square units and a width of 4. Go ahead and on your paper now, draw the same rectangle. Next, I'd like you to draw another rectangle with the same area directly below this first one. But this time, partition it into two parts. The first rectangle will have an area of 40. The second rectangle will have an area of 8. Next, draw a number bond to match the whole and parts of the rectangle. Let's now find the unknown side lengths of the smaller rectangles. What is 40 divided by 4? 10. What is 8 divided by 4? 2. Next, we add. What is 10 plus 2? 12. What is the length of our unknown side? 12 units. Next, I'd like you to pause the video here to explain what connection you can make with the number bond and the area model. What connections did you make? Both the number bond and the area model show whole and parts. 48 is represented here, and 48 is represented here. The parts here, and we see the parts here. We can see in the number sentences also that the parts are divided by 4, which is the width of the rectangle. Now we're going to partition the same area of 48, this time as 2 20s and 8. Next, I'd like you to pause the video here to draw a number bond that matches the whole and the parts of this rectangle. Then solve for the unknown side lengths of the smaller rectangles. Welcome back. Go ahead and take a moment to compare your work with mine. You'll notice that the number bond contains 3 parts this time: 20, 20, 8. And that matches the parts of our rectangle. Go ahead and pause the video one more time for this problem to explain why different ways of partitioning still gives us the same correct side length of 12 units. Even though we partition in different ways, we still get the same correct side length of 12 units because we're starting with the same amount of area, 48 square units. We're just chopping it up differently. The sum of the lengths is still the same as the whole length. Here we have a rectangle with an area of 96 and a width of 4 units. I'd like you to pause the video here to partition this rectangle two different ways. Then create two number bonds to match the whole and parts of the rectangles. Welcome back. So, how did you partition the area of 96? The first way I did it was decomposing 96 into 80 and 16. I then divided both parts by the divisor of 4, which equals 20 and 4. And then the sum is 24. The second way I did it was decomposing 96 into 40 plus 40 plus 16. Again, I divided each of the three parts by 4, which equals 10 plus 10 plus 4, which again, the sum is 24. You know, there are so many ways that we can decompose 96, but why didn't I decompose 96 as 90 and 6? Well, if we divided 9 tens by 4 and 6 ones divided by 4, we would end up getting a remainder with each one. 90 divided by 4 has a quotient of 22 and a remainder of 2. 6 divided by 4 has a quotient of 1 and a remainder of 2. The expression 96 divided by 4 can describe a rectangle with an area of 96 square units. We're trying to find out the length of this unknown side. What is the known side width? 4. Four times how many tens gets us as close as possible to an area of 9 tens? 2 tens. Let's give 2 tens to the length. Next, let's record 2 tens in the tens place. What is 4 times 2 tens? 8 tens. And how many square units is that? 80 square units. How many tens remain? 1 10 remains. Let's add the remaining 10 to the 6 ones. 1 10 and 6 ones makes 16. We now have 16 square units remaining and a width of 4. Four times how many ones gets us as close as possible to an area of 16 units? 4 ones. Let's give 4 ones to the length. What is 4 times 4? 16. We have 16 square units. We had 16 square units to divide, and we did. we have no more area to divide. So what is the length of our unknown side? 2 10s, 4 1s, or 24. And our quotient tells us that length. How can we express the length of the unknown side using distributive property? Let's start with the first part of 80 square units. What expression can we write to illustrate how we determine the unknown side length of this part? We did 80 divided by 4. And this other part? 16 divided by 4. Go ahead, and if you haven't done yet, write this equation on your paper, and then go ahead and solve. We just solved 96 by 4 using the area model in different ways. I'd like you to go ahead and pause the video here and review our work. See if you can explain our work by reconstructing what we just did, step by step. See if you can determine how they differ from one another. We solved 96 divided by 4 in 2 different ways using the area model. First, we started with the whole rectangle, and then we partitioned it. The second way was to go from one place value at a time and make the whole rectangle from parts. Today's assignment is here on the screen. Go ahead and take 10 minutes to work through these problems. And then, of course, if you have additional time, feel free to work through any other problems on the pages. For today's lesson, we used an area model to solve division problems without remainders. Great work for today. Be sure to check in with your teacher, and we'll see you around here soon for another Eureka Math lesson. Enjoy the rest of your day.